Okay, today we're looking at curve sketching. Now we've done a lot of work on different types of differentiation, and recently we looked at how to work out where stationary points were and what type of stationary points they were. Now we're going to pull all of that together and want to be able to go from an equation to be able to draw the function. And we're going to do that by identifying features such as stationary points, routes where the function crosses the x-axis, and y-intercepts where it crosses the y-axis. So we're going straight onto our example on page 18. So first thing we're going to look for is the y-intercept. That's where it crosses the y-axis, and that happens when x is equal to 0. So I'm just going to substitute x equals 0 into my original function there. So y is 2 lots of 0 cubed minus 3 lots of 0 squared. So y is 0. So our y-intercept is 0, 0. Now we're going to look for the x-intercept, or intercepts. This is the roots, and it's more likely that there's more than one place where there's an x-intercept. And this happens when y is equal to 0. So again, I'm going to substitute that in to the original function. So 0 equals 2x cubed minus 3x squared. I want to solve for x, so I'm going to factorise, taking out common factor of x squared. I'll have 2x minus 3 equal to 0. So either x equals 0 or x equals 3 over 2. So our two x-intercepts are 0, 0 and 3 over 2, 0. Now when you're doing these type of questions, we are going to be working out lots of things, so it's good to keep them organised, either by keeping them together in a bubble like this or underlining your final answers, because when we come back to sketch at the end, we're going to need to gather together all the things that we've found. So we have where it cuts the y-axis, where it cuts the x-axis. Now we're going to look for stationary points. And again, it's much easier if you keep everything you need together. So I'm calculating stationary points. I've rewritten the name of the function because that's what I'm starting from. Stationary points occur when the gradient is 0. So I'm going to differentiate, and then I'm going to make it equal to 0 and solve for x. So dy by dx is 6x squared minus 6x. I'm going to make it equal to 0 because stationary points have a gradient of 0. And I'm going to take out a common factor, in this case of 6x. In the brackets, that will give me x minus 1. So either x is equal to 0 or x is equal to 1. Now for the stationary points, I need to also find the y coordinate. So I'm substituting back into my original function. So when x is 0, y is 2 lots of 0 cubed minus 3 lots of 0 squared, which is 0. And when x is equal to 1, y is equal to 2 times 1 cubed minus 3 times 1 squared, which is 2 minus 3, which equals minus 1. So the 2 points that I have are 0, 0 and 1 minus 1. So I've now got my x and y intercepts and my stationary points, but I need to know what kind of stationary points they are. So next we're going to be finding the nature. So I'm going to do a nature table for each of the points with the headings x, dy by dx and slope. I've got a note of the derivative here so that I can do my calculations based on that. So my first point was x was equal to 0. At that point I've got a gradient of 0. I'm going to do a little bit before that and a little bit after it. My second point was where x was equal to 1. And I'm doing a little bit before that and a little bit after that. And again, the gradient exactly at that point was 0. So a little bit less than 1, a little bit less than 0, I'm going to do -1. So 6 times -1 squared minus 6 times -1 is 6 plus 6, which is 12. So I've got a positive gradient at -1. A little bit more than 0. Now I can't actually put 1 there because at 1, when x is 1, I know that I've got another stationary point. So I'd like to know what's happening in between these two stationary points. Between these 2 points, is my curve decreasing or is it increasing? So I'm going to pick the value of 1/2 because that's in between both of those. So I'm going to say 6 times 1/2 squared minus 6 times 1/2. Now 1/2 squared is a quarter, so that's 6 quarters minus 3, which is 3 is 12 quarters, so that's 6 minus 12 quarters, which is -6 quarters or -3/2. So I've got a negative value there. Now a little bit less than 1, I can also use that 1/2, and I've already calculated that that's given me a negative gradient. A little bit more than 1, well, I can go all the way to 2. I don't need to use a fraction here because there's no more stationary points after that. So we're going to substitute that in. So I've got 6 times 2 squared minus 6 times 2, which is 24 minus 12, which is 12. So I have a positive value in here. So my slope for the first point, it's increasing because it's positive, stationary, then decreasing. So that's a maximum turning point. The second point is decreasing, stationary, increasing. That's a minimum turning point. So the summary of those stationary points, so I had a maximum turning point at 0, 0, and a minimum turning point at 1, -1. I'm also just bringing back the x and y intercepts here so that I've got all the information together when I start to sketch my graph. So I'm just going to draw some axes in here. Obviously you'll be using a ruler when you do it. And I'm going to start to put on the information. I'm going to start with the turning points. So I have a maximum turning point at 0, 0. So I know the shape is a maximum. So it's like an unhappy smile there. The minimum is at 1, -1. So I'm going to go along and put the 1, -1 as a minimum. I know that the only place I cut the y-axis is 0, 0. So I'm not cutting this line anywhere else with this curve. But I do cut twice on the x-axis. Once at 0, which is there, and the other one at 3 over 2. Remembering that this is 1 across, so 3 over 2 is going to be somewhere over here. So I'm just now going to sketch in the rest of the curve. I'm just joining the dots of what I've already drawn. And now I can add in my information. I've got a 0, 0 here. I've got a 1 minus 1 here. And I've got a 3 over 2, 0 here. And that's me completed the graph sketch, making sure that all the information is on. We're not drawn to scale here. We do want it to look like the function, so try to draw it carefully when you're drawing it. But it doesn't need to be a work of art. All the information needs to be on it though.